So hello and welcome everyone. Welcome to the post contest analysis of Weekly Coding Contest 161. My name is Jay Dalsaniya and in this stream I'm going to provide the post contest analysis for the same. I hope everyone gave the contest and here you are for the upsolving of the questions. So without any delay, let's start the video. So the first question that we are going to see right now is AND is equal to OR. So here you will be given an array of size n. There is a correction over here that the array which will be given will be a sorted array. In your problem statement it will be mentioned. Okay, so the array is of size n that contains only non-negative integers, means only positive integers, and you are supposed to find out all the subarrays whose bitwise AND is equivalent to bitwise OR and return the count of all such subarrays. So let's try to see what the problem statement is saying with some examples over here. So if you are not aware about what is bitwise AND, then it's a prerequisite for this question, bitwise AND and bitwise OR. So over here, let's take an example over here. Let's take 1, 2, 3 and 4. So here the size of the array is 4 and you are supposed to find out all the subarrays whose bitwise AND is equal to bitwise OR. So here I will note down all the subarrays 1, 1, 2, 1, 2, 3 and 1, 2, 3 and 4. And here all the subarrays that are starting at index number 1, and now here all the subarrays that are starting at index number 2 and all the subarrays that are starting at index number 3. Okay, so here there is a thing to note. Basically, what is the truth table of AND logic? Basically the bitwise AND and bitwise OR. It says that if you have one set bit and if you do AND with another set bit, you will get the output to be 1. And here if you have 1 over here and another is also bit is also 1, basically you will be getting the output as 1. This is an observation inside the truth table of bitwise AND and OR. So here we have written down all the subarrays. So tell me one thing, which subarrays you will be getting the answer of bitwise AND and bitwise OR equivalent? Okay. So here there is a catch over here. The solution revolves around an observation, and the observation is that if you want to find the subarray, then that subarray should contain all the equivalent elements, that all the elements should be equal in that subarray. Okay, or let's say there should be a single element inside the subarray. Okay, so here let me tell you, if you will find the bitwise AND, then only this 4 subarrays that are containing single element, you will find bitwise OR and bitwise AND to be equivalent, and there is a reason. So if you do, there is a number A, and if you do A and A, what you will be getting? You will be getting A. There is a number A, and if you do OR with it, then you will be getting what? You will be getting A in the output. Okay, so this says that all the numbers should be same for the output to be equal. Okay, so now let's take one more example, example number 2. So what I will do, I'll take arrays something like this, 2, 2, let's take 3, 3 and 3. And here what is the size? Size is equivalent to 5. So find out all the subarrays that have similar elements. So one of the subarray with index 0, 1, 2, 3 and 4 will be this, and then this one. Then here starting with index number 2, 3, then 3, 3 and this 3 and 3. Okay, and for this you will have more subarrays something like this. Let's take this somewhere else. Now index is starting with all the subarrays starting with index 1. You will be having only one subarray that contains similar elements or duplicate elements. Now this is for indexes or the subarray starting with index number 2. Now let's see all the subarrays starting with index number 3, which has all identical elements. Now this is the subarray starting with index number 4, which has all the identical elements. So here I equals to 0, here I equals to 1, this is I equals to basically what? 2, I equals to 3 and I equals to 4. So this is the total count. This is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are in total 9 subarrays in which bitwise AND and bitwise OR is going to be same. Okay. So what will be the approach of it? How will you find out all the subarrays having identical elements? So basically, as I mentioned, the array which you will be given, it will be sorted array. It will be sorted array. So whenever I say sorted array, you need to understand that duplicate elements will be adjacent to each other. Something like this, right? Do you agree? Duplicate elements in the sorted array will be adjacent to each other. Yes, totally. So now here basically you can use let's say you can count the adjacent elements that are identical to each other and just count what is the frequency of the subarrays having bitwise and equal to bitwise or. Okay, didn't get, let me explain. I'll take an example. Let's take an array that contains all identical elements. Now here n equals to 3. How many subarrays will be there? Okay, so for index number 0, I have 3, 3, 3, 3, 3 and 3. Now for index number 1, how many subarrays will be there? So I'll have 3 and 3, 3. Now for index number 2, all the subarrays starting with index number 2 having identical elements, it will be only this. Okay, so for the first index, how many elements did you get? You get 3 elements. For the second index, like for the index number 1, how many elements did you get? How many subarrays did you find? 2. And for this one, how many subarrays did you find? Only 1. So this is what? 3 plus 2 plus 1 is equivalent to what? 6. And this is a formula for sum of n natural numbers, n into n plus 1 divided by 2. Okay, so what you need to do, basically, let's take here I have taken the value n, right? But that should be equivalent to the count of the identical elements. Let's take one more example. Okay, so let's say 2, 2, 3, 3 and 3. Now let's calculate the answer. Okay, so what I will do, I will start the loop over here. Okay, there's an outer for loop that is starting with the index number 0. Okay, now there's an inner for loop. It will find out how many identical elements are there. Okay, so I'll say I'll have a count variable over here. Count variable, something like this. Count is initially 0. Now I have included one element, so count will be what? 1. Now increment the value of j. Okay, fine. So is this an identical element? Yes. So increment the count. So now count becomes what? 2. Okay. Now if you increment the value of j, what is this element? Is this identical? No. Okay, fine. So this means you have got 2 identical elements. Now how many subarrays will it calculate? It will calculate count into count plus 1 divided by 2. So this will be 2 into 3 divided by 2. That means 3 subarrays. And if you want to see, we can find out all the subarrays. For I equals to 0, 2 and 2, 2. And for I equals to 1, there is a single element. Okay. So in this way, we'll keep on finding out the count of identical elements and just use the formula and keep on adding this to a sum. Okay, let's take an answer variable and let's continue with this. So answer will be initially 0. So add this to the answer. So now answer will be equivalent to 3. Okay, so now again start the iteration, find out the identical element. Okay, so now here you will not bring this I plus plus. What you will do, you will bring this I over here. Okay, so now I basically points to this position. Okay, because now this is a new set of identical elements. Okay, now find out how many identical elements are there. So here j is at the same index where I is present. So count will be initially 1. Now increment the value of j. So now j states this element. Is this equivalent? Yes. So now count will be plus 1. So count becomes 2. Now increment the value of j. Okay, over here. Now this is also 3. So increment the count. Count says 3. Now if you increment the value of j, j will be out of bound, right? So now how many identical elements did you find? You found 3 identical elements. So that would be 3 into 4 divided by 2. This will be equivalent to 6. So add this 6 over here in the answer. So you'll be getting answer is what? 9. Okay, so you have to count just the identical elements and use the formula n into n plus 1 divided by 2. Okay, so now let's try to code this approach and let's try to see what do we get in the output. Okay, so I'll be coding in Java, but I will attach the link for C++ solution in the description as well. Okay, so you can have a look over there. Okay, so here one thing to note is basically this is the function that we have to complete, and it basically returns an answer of type long. It takes a response of type long, right? We need to return an answer of type long. And there's a reason. Why there's a reason? Have a look at the constraint. Constraint says n is basically as large as 2 into 10 to the power 5. Okay, so that means if all the elements are identical, that formula n into n plus 1 divided by 2 will be out of the range of integer. So that's why we use long over here. Okay, 10 to the power 5 into 10 to the power 5 plus 1 divided by 2 will be something around 10 to the power 11, right? Or something like that. Okay, so I'll use an answer variable, and that answer variable will be of long data type, and in C++ long initialize with answer equals to 0. Okay, so now I'll start an iteration from the index number 0, I is lesser than n, I plus plus. Okay, so this indicates the set of identical elements. I indicates the starting position of identical elements. Okay, I'll take one more pointer, that is j, and I will use a count variable over here. See, and count basically I'll keep this as, let's say, 0 initially. Now I'll say while j is basically lesser than n, it should be inside the range. And if I find if array of I is basically equivalent to array of j, then what I will do, I'll increment the value of j and I'll increment the count as well. I will increment the count. Okay. And if this is not true, what should I do? If I is not equivalent to j, then I should break out of this loop, right? Else just break out of this while loop. Okay. And when you break out of this while loop, what you are supposed to do? You are supposed to increment the value of answer. So answer will be what? Count into basically count plus 1, and I'm supposed to divide this value. Count into count plus 1 divided by 2. And then what you will be doing? Where should you place your I? Okay, in case of, let's say, you have 2, 2, 3, 3 and 3. Okay, so initially what you will be having? You will be having I at the j over here, then you will increment j over here, and then you will increment j, and you will find out that the element at the ith index is not equivalent to j. Is this right? This is what will be happening. So what do you think, where you should increment the value of j? So basically you will update the value of I at the jth index. Okay, so what you will do, you will say I is equal to j minus 1, because after this I plus plus will take place, so we'll increment the I. So what I'm doing now, I'll update the value. This line number 72 will update the value of I over here. It will bring I somewhere over here, and this for loop I plus plus will take place, and so I will be over here then afterwards. So one more thing. So here if you observe, we have used count as integer. So here also we need it to be long, because it will be out of the range when you do the multiplication. Okay. And at the end, what you need to do after the iteration, you just need to return the value of answer variable. Let's try to compile and let's try to see. Okay, so it's working fine, and let's try to submit and see what do we get. And we can see that the problem has been successfully submitted. It's a pretty easy question, just simple observations are required. And what about the time complexity of this approach? The time complexity here, you can observe you are iterating over every element only once. Either j is iterating or I is iterating, right? So the time complexity is linear, and space basically is order of 1. Okay. So this was our first question, and now let's see the next question of the contest. So the next question is maximum difference cool prime. Okay. So let's try to understand what the question is trying to say. So in this question, you will be given an array of size n containing positive elements. Okay. Find the maximum value of modulo I minus j such that ai and aj are co-prime of each other. Co-prime means the highest common factor or GCD of those two elements should be 1. Okay, the greatest common divisor should be equivalent to 1. Like 3 and let's take 8. They have GCD equals to what? 1. So if there are no co-prime pairs in the array, then you have to return minus 1. And there's a note, a very important note, array of I is less than or equal to 1000. Okay, all the elements are less than 1000, and I and j are not necessary to be different. That means you can, the array can contain a single element, and that single element basically, if it is forming a co-prime pair with itself, okay, then the difference is a valid answer. That means you have a single array element 1, okay, and 1 is co-prime with itself, right? So the difference of index will be what? 0 minus 0. Let's take 0 minus 0 as the index. So you'll be getting 0 as the output, okay, and not minus 1 in that scenario. Okay, no worries, I'll explain the question and everything. Okay, so let's start and understand what this question is saying. Okay, so basically let's take some examples. So here, first of all, before understanding and before moving on to the implementation or anything, so what the question says, you have to find out the pairs of co-prime numbers. Okay, and you have to take the absolute difference between those two numbers, and you are supposed to find out the maximum value of I minus j. And there is one more note. That note says basically I and j can be same. That means you can access the same element and then you can think about it, right? So I'll take one example over here. Let's take an example. So first of all, I'll explain what is co-prime. So co-prime basically means that the GCD, that is greatest common divisor of those two numbers, let's take two numbers as a and b, if they are co-prime of each other, then you will be having the GCD to be equivalent to what? 1. Okay, so you have to find out all the co-primes, and you are supposed to maximize this I minus j, the difference of their indexes. So let's take some small examples over here. Let's take 3 and 5 and 8. Okay, and n equals to 3. So here what you can do, the brute force approach, you can try out all the different pairs and find out the GCD of the pair, and then if the GCD is 1, then calculate the difference of the index, compare with answer, and keep on updating in that manner. So I will apply a brute force approach over here. Okay, so here basically 3, and I will pair it with 5, 3 and 5. So R3, what is the GCD, greatest common divisor of 3 and 5? For 3, what are the divisors? 1 and 3. For 5, I have 1 and 5. The greatest common divisor is 1 between them. So yes, 3 and 5 are co-prime of each other, and I need indexes over here, 0, 1 and 2. What is the difference of their indexes? I minus j. Let's take I equals to this and j equals to this. So I'll be getting 1 as the difference. So let's take answer. Answer was, let's say, minus 1. Initially, let's take it as minus 1, not possible. Okay, so I'll update the answer as 1. I got the maximum difference to be 1. Now let's take another pair. Let's take 3 and 8 in this scenario. 3 and 8. So is 3 and 8 co-prime of each other? So let's see. 3 has got 1 and 3, and 8 has got 1, 2 and 4. Yes, the greatest common divisor is what? 1. And what is the I minus j difference? 0 minus 2 modulo, I'll get 2. So I got 2, and it is greater than answer, so update 2 over here. Okay, so now let's take one more example. So 5 and 8 also forms a pair, but I don't think the difference of their indexes will be greater than just 2, right? It is 1 minus 2, and you will be getting 1 over here. So answer is already maximized here, right? So you got elements, 2 elements, 3 and 8, and they are co-prime of each other, and the output comes out to be 2 in this scenario. So output for this test case is equivalent to 2. Okay, so you have to find out all the pairs. The brute force approach can be finding out all the pairs, and in each and every pair find whether they are co-prime of each other or not, and if they are co-prime, then find the difference of their index and keep on updating one answer. Okay, so finding all the pairs, it will take around what, n square amount of time, and let's have a look what is the maximum value of n. It is 10 to the power 5, so obviously 10 to the power 10 operations it was case, right? So it will not be accepted. The brute force approach is not going to get accepted. And one more thing, there's a prerequisite in this question that if you're not aware about how to find GCD, there's an algorithm, Euclidean GCD algorithm. So I would highly recommend that before solving this question, have a look at that GCD Euclidean algorithm. Okay, so it will be helpful to you whenever you want to find GCD of any two numbers. Okay, so brute force idea, we are very well aware. We can find out all the pairs. Now we need to do better than this. Okay, so if we are focusing on doing better than this, then what can we do here? Okay, so let's see some examples. So let's take one example over here, and I will include two elements over here, 3 and 8 in this scenario. Okay, so 3 and 8, so n value is equivalent to 2, and find out how many co-prime pairs are there. So here I can form one pair that is a co-prime of each other, 3 and 8, and the difference of their indexes. So I'll get 0 minus 1, that is 1, and hence the output answer comes out to be 1 in this scenario. So this example number 1 is okay. I can get to know that this is what we are doing. So what is special about it? Let's take. See, observe some things. So mainly what I'm trying to explain you is that every time, is it required to find out all the pairs? No, every time it's not required. And why is it not required? Observe this example number 2. Let's take some repeated elements over here, 3, 3 and 8 and 8. Okay. So, and what is n equals to? N equals to 4 in this scenario. So now here, find out how many pairs are possible. And you know that you are supposed to basically maximize I minus j, that is the co-prime pair maximization of their indexes, right? You are supposed to maximize this for any co-prime pair. So now what you are supposed to do? Finding out all the pairs. So can I say that 3 and 3 are co-prime of each other? If I want to form this pair, is it valid pair? No, it is not valid pair. So can I say 3 and 8? Okay, so here I equals to what? 0, and the other index is what? 2. The element is what? 3, and element is what? 8. 3 and 8 are co-prime of each other, yes. What is the value of I minus j in this scenario? It is 0 minus 2. And what is this? It is equivalent to 2. Now answer becomes 2 in this scenario. Initially, let's take it is minus 1. Now update it to be 2. Now here, You can see there are two appearances of 8. Now let's pair with another appearance of 8. Okay, so now here I is equivalent to what? 0 and j is equivalent to what? 3. So this is 3 and 8. What's the difference? I minus j. It is what? 0 minus 3, and this is what? 3. I got a maximum answer. Now the maximum answer is what? 3 in this scenario, not 2. So what did you observe here? When you had multiple appearances of 8, what did you observe? If you can observe, you can see that the maximum index of 8 is what? 3. The last index of 8. Okay, there are duplicates of 8, right? Now the last index of 8 is what? The maximum index of 8 is 3. So here this 3 basically forms a pair with the last index of 8, and it gives the maximum answer that is possible between a pair of 3 and a pair of 8, like a pair of 3 and 8, right? So here let's take for a few more examples, like what other pairs can we form here. Now let's take I is equal to what? Let's take 1, and j is equivalent to what? Let's take 2. This is 3 and this is 8. What is I minus j? 1 minus 2. That will be equivalent to 1. It is not maximum. Okay, fine. Now let's take I equals to 1 and j is equivalent to what? 3. This is 3 and 8. What is it? 1 minus 3. You will get 2 over here. And this is not maximum because answer can be 3. Can you observe anything? See, if there are duplicate elements, there are duplicate elements. And the question says that there can be duplicate elements. It has not been mentioned you will be getting all the unique elements. Okay. It says given an array of size n containing positive elements. It is not saying that you will be getting only unique elements. Now, I have taken the example in which duplicate elements are possible. So here, do you think all the pairs that 3 is forming with 8 is required? If your answer is no, then which pair is required? So here you can say the minimum index of 3 and the maximum index of 8, basically they give the maximum answer over here. Rest all the pairs give an answer which is less compared to the maximum answer. Okay, if I want to generalize this thing, then what can I do? Okay, if I want to generalize, let's take A and B. There's an array that contains A and B, where A and B basically are co-prime. A and B are co-prime of each other. And now here, what will be the answer? If A and B are co-prime of each other, then I know answer will be what? 0 minus 1. Then answer will be 1 for this co-prime pair. And if my answer was initially equivalent to minus 1, then I will be updating the answer to 1. Now if I increase the appearances of A and B, what will happen? If I include AA and BB over here. Now here I want to see what is the maximum answer. We saw that the smallest index of A and largest index of B is required. So that means maximum index of A, this is minimum index, right? Minimum index of A is required, that would be 0, and maximum index of B, that is equivalent to 3. This is required. Rest all the ideas, I don't care about it. I don't need them. Okay, so I need minimum index of an element and maximum index of an element. So finding out all the pairs will not be beneficial over here. So what I will do basically, I need to keep the track of minimum index and maximum index for every element. Now we will be confused like, why do we need to keep the minimum index and maximum index of both the elements? So here you are saying that minimum index of A minus maximum index of B is sufficient. Okay. So you are saying that I only need minimum index of A, I don't need maximum index of A. And you are absolutely true. You don't need to keep the track of maximum index of A, that is 1. And you don't need to keep the track of minimum index of B, that is 2, because they don't give you a valid answer. So wait a minute, what if I change the values in this manner? What if B appears over here and A appears over here? So this will be what? 0, 1, 2 and 3. Now tell me in this scenario what is the answer? It is minimum index of B and maximum index of A that gives the maximum answer. So that this is minimum index of A, that is 0, minimum index of B, and maximum index of A. This is minimum index of B, that would be 0, and maximum index of A, that is what? 3. So this gives you the maximum output, right? This gives you the maximum answer, right? So here my basically explanation is that basically you need to keep only 2 indices of every elements. You need to just keep them, right? You just need to keep the track of only 2 types of indexes. One is the minimum index and one is the maximum index of every element. Okay. And what is the range of elements? The element can be a of I can be less than or equal to 1000. This is the range. So here basically what we can do, we can pre-calculate all the indexes. So what I will do, I will basically find out, I'll keep the maximum index and the minimum index of all the elements, okay, from 0 till 1000 in maximum array and minimum array. Okay, then what I will do, here the range of the array, basically the array element, is it 0? Let's see, is it 0? Yes, no, it is equivalent to 1. Okay, fine. So 1 index is not required. So 0 index is not required. I need index number 1. So I'll start the iteration. I'll take this one. I'll compare it with itself because here it can be same. I equal. So basically I'll take one element from maximum index. I'll take one element from minimum index. Okay. Then what I will be doing? I'll take the minimum index, maximum index of the other element and minimum of the other element. Okay. So let me explain with the example here. So I'll take the same example, this one. And I'll show you the dry run and then you will get to know what we are supposed to do here. So this is the example 3, 3 and let's try to find the answer of it. Okay. So now let's say you have an array, something like this, that stores the maximum index of every element and there is an array called as minimum that stores minimum index of every element. So for 3, what will be the maximum index of 3? It will be 1. What will be the maximum index of 8? It will be what? It will be 3 over here. What will be the minimum index of 3? It will be 0. What will be the maximum index of 8? Sorry, the minimum index of 8. It will be 2. Okay. Now what you will do? You will take maximum index of 3 and you will take minimum index of 3 and calculate the answer. Okay. So let's take answer. Answer, let's take initially it is equivalent to -1. Okay. So here if I take maximum index of 3 and minimum index of 8, I am talking about this pair. Okay. So here you can observe, will it give you a maximum answer? No, basically this is 0 minus 2, right? 0 minus 2, this is basically, this is the pair, right? 1 and 2. So here what I will be getting? I will be getting 1 minus 2. So what is this? This is 1. So obviously answer is -1. So it is 1 is greater than answer. Okay, fine. Now what you will be doing? Now you will interchange. So you will take maximum index of 8 and minimum index of 3. Okay, so what do you get as the answer? This will be 0 minus 3 and you are talking about this pair. Minimum index of 3 and maximum index of 8. So this is what? This is what? This is 3 and you got a maximum answer. So this comes out to be 3. And rest all the pairs are not required. So here you found out that this pair maximum of 3 and minimum of 3 does not give you a maximum answer. Then why you are taking these things? Like why are you keeping the track of maximum of 3 and minimum of 8? So let me tell you, see what about this kind of test case? So here you got the maximum answer when you had maximum of 8 minus minimum index of 3 and you took the modulo of it and what did you get? You get 3 minus 0, that is 3. So remember this thing, you got answer over here in this manner. Now I'll take different arrangement of the array. I'll take 8, 8 and 3 over here. So this is maximum and this is minimum. Okay. So now pay attention. So for 8, what is the maximum index? So for 8, 0, 1, 2 and 3. Maximum index is what? 1. And what is the maximum index of 3? It is 3. What is the minimum index of 8? It is 0. What is the minimum index of 3? It is what? 2. Now find out all the answers. So first of all, I'll take maximum of 8 and minimum of 3. So what I will be getting? Answer says initially what? -1. So this will be 1 minus 2 modulo. It will be 1. So replace this, you will be getting 1 over here. Now I will take basically these two values. Okay, so this is minimum of 8 and maximum of 3. So this will be 3 minus 0. I'll get 3 over here. And I got a maximum answer. So this comes out to be 3. So this pair, we are talking about this pair. This is 3 and 0. I'm talking about this thing, 3 and 0. And earlier also, which answer we got? We got this as an answer, right? Maximum of 8 and minimum of 3. You can observe maximum of 8 and minimum of 3. So here also you got basically maximum of what? Maximum of 3 and minimum of 8 as the answer. Okay, so the reason why we need minimum and maximum of every element is that the positions can interchange. You'd never know which element will be having at which position. So that's why you need to keep the track of maximum and minimum index of every element, and then you can iterate over this maximum and minimum array and find out all the pairs and compare two things. So just a summary, what will be your answer? So the algorithm works something like this. We'll be creating what? Maximum array, and maximum array will be of size 1001 because you need array elements from 1 to 1000. And there will be a minimum array and its range will be what? 1001. So this minimum I will initialize with infinite, and you can initialize this maximum with, let's say, -1, just for initialization, because you will update the values. Then you will basically put the values in the maximum and minimum array. Okay, fine. Then what you will be doing? You will verify all the pairs, all the 1000 elements. So you will start the iteration. You start from I equals to 1 to what? I is less than or equal to 1000. Now you will check all the elements. J equals to what? See, here I will start the iteration from j equals to I, because here it says, if you remember the note, it was saying that the elements basically I and j can be same. That's why I have taken the iteration from j equals to I. So to what? J is less than or equal to 1000. Now I will be checking if the element exists. So that means the maximum will not be -1, right? Maximum of I is not equal to -1, and the, let's say, maximum of j basically is not equal to -1. If the element exists, if the element basically does not exist, then the value is going to be what? -1. Okay, and I'll use OR over here. In this scenario, what you should do? You should basically continue, because the element does not exist, so you don't need to find out its GCD. Okay, fine. But here also, whenever you get two elements that are already present, you need to verify whether they are co-prime or not. Okay, so let's say I'll verify whether GCD of I and j is co-prime or not. Let's say I'll store it inside temp. Okay, now I and j, if their GCD is not basically, let's say, 1, if temp is not equal to 1, then that means they are not co-prime. So here also I'll continue. I don't need to calculate the answer. Okay, fine. And one more thing I forgot to mention over here, we need an answer variable. So I'll take answer variable to be -1 initially. Okay, -1, because the question says when answer is not possible, output is what? -1. Okay, fine. So now let's say if they are co-prime, GCD of I and j are co-prime, then what will be the answer? So as I mentioned, answer will be what? Answer will be basically maximum, because you need maximum of I minus j. Okay, it will be maximum of answer, and what you will be doing? You will be taking the absolute of what? Maximum of I minus minimum of j. Okay, imagine this thing: 3, 3, 8 and 8. Okay, let's say I equals to 3 and j is equivalent to, over here, j is equivalent to I. 8 equals to 3 and j is equivalent to 8. I and 3 over here are elements. Okay, and if you change the ordering, I 8, 8, 3, 3, this is the ordering, then I will be what? 8 and j will be what? 3. And you know the maximum will be what? Maximum will be over here. This will be the maximum pair that you will be getting. Okay, in both the arrays, these are two different examples. So for the first one, maximum of basically maximum of so-called 3 and minimum of 8 is required. So I have taken one maximum, one minimum. Or else, if the ordering is different, I'll try out the other thing, that is maximum of answer and absolute of, now I'll take maximum of j minus minimum index of I. Okay, whatever is the answer. And now the for loop keeps on iterating. Okay, this is the end of the for loop. And at the end, the last step is what? Last step is to print the answer. Print the answer. Okay, so this is the algorithm. Okay, take a maximum array to store the maximum index of any duplicates and minimum index of any duplicates. If there are not, maximum and minimum of element will be equal. Then put the values in maximum, then iterate over all the possibilities. If the element is not present inside the array, then continue. If the element is present, then are they co-prime? Yes, if they are co-prime, then the value will be equivalent to 1. If they are co-prime, then take this two value, maximum of I, minimum of j, or take maximum of j, minimum of I. And this is the logic of it. Okay. So now let's try to code this approach and let's try to get this done, right? Okay. So now here, what do we need? Here we need basically two different arrays. That is, one is maximum. And what will be its size? Its size will be this, and mn is equal to new int 1001. Okay. Maximum and minimum. Now start the iteration. So fill the arrays mx and mn. Okay. So what I will do, I'll use arrays.fill to initialize the value of mx. So any index, any positive index should be greater than what is the initialized value. So I'll take -1 over here, and here I'll take arrays.fill mn, and here I'll take let's take n+1. Every index will be less than n+1. So I've taken minimum initialization with n+1. Now start the iteration of this array. Integer I equals to 0, I is less than n, I plus plus. Okay, now I'll change this name to ARR. And here ARR of, basically I'll try to initialize. So maximum of ARR of I, its index will be what? Its index will be maximum of the value already present for that element, and it will be compared with what? I. And for minimum of index, I'll be storing math.minimum of minimum ARR of I. Okay, I'm just storing the maximum index and minimum index of every element. This is what I'm doing. Okay, so this is the initialization. So filling mx and mn arrays. Okay, that's it. Now find out all possible pairs in the range 1 to 1000. So I'll say basically, I'll start the iteration from I equals to basically 1, I is less than or equal to 1000, and I plus plus. Now for integer j equals to 1 and j is less than or equal to 1000, j plus plus. Okay, see here I should start the iteration with I. Okay, fine. I'll add some space over here. Now I will check if the elements exist. If mx of I is not equal to, basically if it is equivalent to -1, or mx of j is equivalent to -1, that means their values have not been updated. If values are not updated, then that means elements are not present. Continue. Else what I will be doing, I'll be writing down the GCD code. I'll check if I and j are GCD of each other or not. And here what I will be doing, I'll store the answer inside my temp. Okay, in your C++ you already have a GCD code written, but here I'll code the GCD function, Euclidean GCD algorithm. Now if they are not co-prime, the value of temp will not be equal to 1. If it is not equal to 1, then continue. They are not co-primes. I don't need them. If they are co-prime, I need the answer variable. Where is the answer variable? Let's create answer is equal to -1 initially. Okay, fine. Now answer is what? Answer is maximum of what? Answer, and I'll take the absolute. I'll take maximum of I minus minimum of j, and the opposite of it, right? And the opposite of it, maximum of what? Maximum of j and minimum of I. This is the opposite of it. Okay. And at the end, after the for loop ends over here, what I will be doing, I simply need to return the answer variable. That's it. Let's try to compile and let's try to see for errors. So GCD, I forgot to write down the GCD algorithm. So here is the function where it ends. So I'll write down, and it will return public static void integer GCD, integer A and integer B. And let's take, I'll say GCD of B modulo, let's say B modulo A, and here I'll pass A, and I'll say if my A becomes 0, I'll return what B, and here basically return this. And let's try to compile run. So working perfectly fine. This is the corner test case that I was talking about. Okay, but and let's try to submit and see, and you can see that the problem has been successfully submitted, right? So let's understand what will be the time complexity of this. So here this is an iteration n, right? So order of n, and here 1000 into 1000. So it's possible that n value can be less than or equal to 1000. So overall this is a nested for loop. It takes 1000 into 1000 number of iterations. So time complexity is this 1000 into 1000, and space is what? 1000 because of this mx and minimum array. Okay, so this is the maximum difference cool prime. And now let's try to see the next question. So now the next question that we are going to see is basically mean size of the array. So this is quite an interesting problem. It has got many observations that you can observe here. So let's start and understand what the question says. Given an unsorted array, okay, it says this array is going to be unsorted of size n that contains only positive integers. Non-negative means positive. You are given an operation which you can perform any number of time, and the operation is you have to choose any two indices where the elements are not same and remove I and j. Okay, so two elements, you can select any two random elements which are not same and you can remove them. But there is a note that after applying or after removing two numbers, the rest of the other elements remain at the same position. They basically do not shift. Okay, so their position are not going to be affected by the elements that you remove. So what you are supposed to do, you can apply the operations any number of time. You have to return the minimum size of the final array after doing the operation 0 or any number of times. Okay, you have to return the minimum size of the array after applying the given operation. Okay, so let's see some examples and let's try to understand how and what we are supposed to do. So this is minimum mean size of the array. So in this question, basically, let's take n equals to 5 and the elements are 1, 2, 3, 4 and 5. So basically the operation is select I comma j where the elements are different, where I comma j is not same, where the elements are different. Array of I is not equal to array of j, and remove those two elements. This is the operation that we are supposed to apply over here. Okay, fine. So now on the given array, what I can do, I can select first of all the indexes. I'll write down 0, 1, 2, 3 and 4. I can select 1 and 5. Okay, so they are removed. The rest of the elements remain at the same position. Now I can select 2 and 3 because they are removed. Now this 4 is remaining, right? Now I cannot pair this 4 with any other element. So the output comes out to be how many elements are remaining? A single element. That means after deleting all elements, only one element is remaining. Okay, so here one more thing to note is that the array is going to be unsorted. And what about the duplicate elements? Yes, the array can contain duplicates as well. Let's say n equals to, let's say 5, and here I'll say 2, 2, let's say 3, 2 and 2. Okay, fine. Now it says the operations cannot select the similar elements. So here I cannot select this 2 and this 2 because the elements are same. So what I can do, I can select this 2 and this 3. So I'll remove these two elements. Now I have all the elements that are identical, right? So the output comes out to be 3 because the size of the array is now 3. Now it cannot be reduced further. Okay, one more last example to understand it in a better manner. So let's take n equals to, let's take 6 over here. Let's take 2, 2, let's take 3, 4 and let's take 3 and 4. Okay, selecting two elements over here, I'll select this 2 and this 3. Okay, fine. Now I'll select basically, let's say 2 and 4. Okay, so this 2 and then this 2 and then I will select 3 and 4. Okay, so now what is the output over here? How many elements are remaining? What is the size of the array? Now the size of the array is what? 0. Okay, so this is what the question is trying to say. Now how to solve this question? Okay, so there are some observations that can be done on seeing different types of test cases. Okay, I will give you some examples over here, some test cases to observe. Let's take test case number 4. Okay, so n equals to 6 over here and I'll say 3, 4, 3, 4 and let's take 5 and 6. Okay, here you can see the elements are these elements. Now I can select what? I can do 3 and 4, right? So this two elements will be removed. Now I can select basically, let's say 3 and again 4, these two elements. Okay, now I can select 5 and 6. Okay, these two elements. So here what is the output? The output comes out to be 0. Okay, so this example is quite different. Okay, let's take one more example and let's take n equals to, let's say 7 in this scenario. I'll take 1, 1, 1 and let's take 2, 3 and 1. So here we have 6 elements and let's take one more element, that is 2 over here. Okay, so now here observe what is happening. So here observe the pairs that you can form. I'll select basically, let's take 1 and 2. Okay, so the first pair is 1 and 2. Now one more pair I want to select. I'll select 1 and 2. So I'll select 1 and 2. Now one more pair, 1 and 3. Okay, fine, 1 and 3. Okay, now what is the remaining size of the array? The array is now of size equal to 1. Okay, now I'll take this kind of example. What is this kind of example? Here basically there are some element whose frequency is the greatest, right? Here what was the frequency of 1? 1 was having frequency of around, let's say 4, right? 1, 2, 3 and 4. 4 elements are there of 1. Okay, so now let's take one more example, same kind of example, where there will be one dominant element. Okay, that means the maximum occurring element. Let's take n equals to 6 over here. I'll take 1, 2, 2, 2, and let's take here, let's take 3. Okay, here the maximum occurring element is what? 3 over here. Okay, so now observe the pairs that we can form. I can form basically 1 comma 2. This is one of the pair. I'll write down as 2 comma 1. Okay, because I want to show you the observation on the dominating element, 2 comma 1. Now I'll take 2 comma 3. 2 comma 3. Which element is remaining over here? You can observe the maximum element, or the dominating element is remaining, whose frequency is the highest. Here the dominating element is remaining. Okay, fine. But here in the other example, in the example number 4, here all the elements were having same frequency, right? 3 equals to 2. Then let's say you had 4 was occurring twice, and 5 was occurring twice. Okay, so basically there were all the elements having same frequency, so you cannot say any one element is a dominating element. Okay, so I'll like to give you some more examples in which there is a dominating element. Dominating element means the element that appears more than half or equal to the half of the size of the array. Okay, the element whose frequency is almost equivalent to n by 2 or greater than n by 2. Okay, that's the dominating element. I'll take few more examples around this test case. Okay, so let's take n equals to, in this scenario, let's take 5. So I'll take 1, 1, let's take 2, 1, and let's take 3 over here. So here, which is the element? So maximum occurring element is 1 and its frequency is 3. So observe, the maximum occurring element will be the one that remains unpaired. Okay, because it is identical and it has got the highest number of occurrences in the array. I'll select 1 comma 2. Okay, so I will select 1 comma 3, and now one element is remaining, and that is the maximum occurring element. Okay, so basically here I can observe the output. I saw two different types of test cases, right, in which there was a dominating element. The example 4, in which there was no dominating element, every element was occurring same number of times, right? Or yeah, so basically here the approach basically can be found by dividing the type of test cases into two types. Okay, there are two type of test cases that you will be finding out. So one is, there will be a dominating element, that means dominating element, and if there is a test case in which there is a dominating element. What does it mean by dominating element? Let's say the frequency of the dominating element, I will call it as mx, will be basically greater than or equal to n by 2. Okay, so in this approach, in this kind of test cases, we observe the output is what? Remaining occurrences of dominating element. Okay, and what about the other type, where no dominating element is there? All of them are basically having same frequency, or the elements that are there, they don't have their occurrence greater than or equal to n by 2. Okay, so no dominating element. So we'll handle and see what will be the output of it. We'll try to observe after completing our first observation, that is, what about dominating elements. So here let's go back to the test cases in which we had dominating elements. So this example, I'll mark down this example as dominating element, and this example also has dominating element, and this example as well. So here basically, what is the frequency of the dominating element? Okay, so the frequency of the dominating element, I will find out the frequency, and I came out to be 4. So now I want to find out how many how many elements from this maximum occurring elements will remain unpaired. Means this indicates the final array. This helps us to get the size of the final array, because this elements will be the one that will be remaining. Okay, those elements will be remaining, and those elements are going to be unpaired. Okay, so what will be the answer? So maximum element, I mean the dominating element, its frequency is what? 4. Okay, fine. Now what are the rest of the other elements? So what is the size of the array? N equals to 7. So can I say rest of the elements are what? N minus mx. So that would be what? 7 minus 4 equals to 3. Okay, these are the remaining elements. So I can I'll write down, this is dominating number. Okay, and these are the remaining numbers. So here basically you can make a pair between the dominating number and the remaining numbers. Okay, you need the elements to be different, right? So I'll make a pair between both of them, and now I can observe that if this remaining element, what is the value of remaining element? It is n minus mx. if the value of the remaining element, basically the remaining elements are what? Are basically, let's say, less than or equal to the maximum occurring, then I can I say my answer will be what? Can I say my answer will be maximum occurring elements minus the pairs that I have found? Minus the pairs that I have found. This is the total amount of pairs I will be finding. What is this? N minus x, n minus mx. It is the remaining number, and this is dominating number. So remaining numbers I can pair. I can get three pairs. I can select one element. I can select three elements from here, and I can select three elements from the dominating one. So here, how many elements inside dominating will be remaining? Here, at the end, only one will be remaining. That is what? Mx minus n minus mx. Okay, fine. So always the output, if you have a dominating number, this is the condition that will help you to identify if you have a test case in which there is a dominating number. Okay, then answer will always be this. Okay, I'll write down the summary and I'll try to help you to solve using what we have observed. Okay, if I see n minus mx, the remaining elements are less than or equal to the dominating number, then your answer will always be the elements or the instances of dominating number which cannot be paired. So that instances will be what? It will be mx minus n minus mx, right? This many pairs will be formed, and inside the dominating number, some elements will be remain. Yes, that's pretty fine. Okay, so remember this thing and let's try to solve the examples that we have seen. So here, what is the frequency? I'll just erase these things. So now what is the dominating number? Okay, what is the dominating number? Here you can see 1, 1, 1 and 1. Its frequency, I'll call it as mx. Mx equals to what? 4. And what is 7 by 2? It is equivalent to around 3, right? So here you can observe this is the dominating number. So yes, I can observe. Now what about the remaining elements? That is n minus mx. You can see output is this, okay? And observe using the formula, you'll get the same output. N minus mx, that is 7 minus 4 is what? 3. So this means 3 pairs can be formed. So can I do mx minus n minus mx? So that would be what? 4 minus n minus mx is what? 3. And this is your output. Can you observe? This is your output. Okay. So now let's see one more example. N is equal to 6. Here, what is the dominating number? 2 is the dominating number. Okay. N by 2. I'm just proving whether 2 is a dominating number. Okay. I told you that dominating number frequency is going to be greater than or equal to n by 2. N by 2 is what? 6 by 2 is what? 3. You can observe dominating number, its frequency is what? Greater than or equal to n by 2. Okay, fine. Now, I'll call it as mx. Mx is equal to 3, dominating number's frequency. N minus mx, the remaining elements. It is what? 6 minus 3 is equal to 3. So you can observe here, you can basically pair the other elements with the dominating number, and what you will be getting as the answer? Mx equals to mx minus n minus mx. So you got here 3 minus 3, that comes out to be 0. So output is 0, and here also what was the output? Okay, so we made a minor mistake or what? Okay, n minus mx, its frequency is through so okay, just a minute. So n minus mx, what did we do here? 6 minus mx. Mx is equal to 3, and okay, so here basically I made a mistake by giving this size. So here there are only 5 elements. So n is 5 over here. So here basically it will be 5 minus 3 because n is 5. So you'll get 2. Okay, so this is the okay. So here you got remaining element as 2 and dominating as frequency 3. So you can observe what is the pair that you can make. You can make 2 pairs. This decides how many pairs you can make, and this decides how many elements will be remaining. So 3 minus 2, that is 1. So output comes out to be 1. Here also you can observe this many pairs are available, 2 pairs, and this is also 2 pairs. And last one observation, this one. Here the dominating number is 1, right? And its frequency is what? Its frequency is 3. N by 2, let's verify dominating number. N by 2 is what? 5 by 2 is equivalent to what? 2, right? Integer value. And dominating frequency is greater than the n by 2. Okay. So here, what is n minus mx? The remaining elements, that would be 5. Okay, so let me check. 5 is the size. 5 minus 3 is equivalent to 2. So here, one element, 2 elements from here and 2 elements from dominating, you can make a pair, and you can observe one element will be remaining. So that is, answer is mx minus 3 minus 2, that would be 1. And you can observe here, one element was remaining. 2 pairs were available. 2 pairs here also, right? So we got to know that if there is a dominating number, how to find the answer, and this comes out to be your answer. Okay. Now we were still focusing on this. What about there is no dominating number?
And the example of no dominating number, you can take it something like this: 2 3 2 3 and 2. Or I'll take something else instead of this: 2 3, and let's take 3 4 and 2 4. Okay, so here basically you can see all the elements are having same frequency: 4 4 2. All of them are having two frequency. So how to get the answer? What will be the answer? So here I'll like to explain in the form of this formula only. Okay, so here if you find out the dominating number, basically the element whose frequency is highest, you will get the frequency is what? 2. And now let's say what are the remaining numbers? N minus mx. What are the remaining numbers? What is n over here? N is 6. 6 minus 2 equals to 4. Okay, these are the different numbers. These are the different numbers. Okay, fine. So I got to know one element is having frequency equal to 2 and the remaining elements are 4. So can you say that if you pair this maximum, that is the element having frequency 2, with the rest of the elements, how many pairs can you get? Can you get 2 into mx number of pairs, right? Like how many pairs can you get? So one pair. So let's say mx, what I'm focusing on over here is that, see, this is the dominating number which I found, but this n minus mx, I got to know that the remaining numbers are like, let's say, big in its frequency. There are many remaining numbers, and I got a number 2, and I'm calling it as dominating number, which frequency is 2. So if I want to pair this 2, I can take two elements from this, so I'll get how many pairs? 4 pairs I'll get, right? I'll get 4 pairs. That is 2 into mx. So you can get 2 into 2, that is what? 4 pairs. You can observe this is one pair. If I'm calling 2 as dominating number, its frequency is 2, right? So 2 into 3, I'll get 2, 3, and then let's say I'll get 2 and 4. So basically, so this number is not the basically number of pairs. It is number of elements removed. Number of elements removed from the array. Okay, I'll take one more example, but be patient. Okay, this observation is quite unique from what we observed. That was straightforward observation, dominating number. Now we don't have dominating number, so there will be one element whose frequency is going to be less than n by 2. Okay, if that element I got to know, and I wrote down its frequency as 2, and the other elements are 4 elements. So I am sure this elements I can pair with this elements. Okay, so from the array, how many elements will be removed? 2 into mx elements. 2 into mx, these two elements can be removed from by pairing over here. Okay, fine. So here you can see always even number of elements will be removed. Okay, so let me explain again with this example. Here I'll take one of the element as dominating element. I'll take mx equals to 2, right? All of them are having frequency 2. Okay, fine. Now what I will do, I'll say, let's say I have selected the dominating element to be 2, and what is the other elements that I have? That is n minus mx, that is 4. Okay, so here I am talking about two occurrences of 2, and here I am talking about 3 4 and 3 4, the other remaining elements. So now what is the size of the array? It is equivalent to 6. Now observe, after pairing one element from this identical element over here, how many elements will be removed? So that means I can remove 2 into mx number of element, that is what? 2 into 2, that is 4 elements will be removed. Yes, absolutely. I'll select 2 and 3. I'll select 2 and 4. So you might be observing, you might be saying that, okay, I can select basically 2 and 3. I'll select 2 and 3, but you are supposed to minimize the size of the array. So that is not an optimal way of selecting elements from this other remaining elements. You should always select 2 and 3, then select 2 and 4. That's an optimal way. So you are supposed to find out in an optimal way. You are supposed to minimize the answer. That's why I'm selecting in this manner. Okay, so how many elements are removed? 4 elements. This is proved by this formula 2 into mx. Okay, so now what will be the size of the array? N equals to 6 minus 4. You will get 2 as the size of the array. Okay, fine. So how many elements are remaining inside the array? 2 elements are remaining, and size of the array is now what? 2. So here you can observe the size of the array has been reduced by even number. Always the size of the array will be reduced by even number, because 2 into mx numbers are removed every time. 2 into mx is what? Even number. That's why size of the array will always get reduced by an even number. Okay, so now n equals to 2. So I'll take dominating number. What will be its frequency? You can see 3 is occurring once, 4 is occurring once. Okay, so this is an updated array after doing one removal. So mx equals to 1, and let's say I'll call it 3. And what is n minus mx? The remaining elements, n minus mx, that would be 2 minus 1. Okay, so dominating element I'm taking it as 3, and n minus mx I'm taking it as 4. So now how many elements will be removed? 2 into mx elements will be removed. 2 into what? What is the occurrence? Mx equals to 1. 2 elements are removed. Yes, absolutely. And n was equivalent to 2, 1 and 2. 2 elements are removed. Hence, again you can see the size of the array has been reduced by an even, has been reduced by basically even number. Here you can see the size of the array always keeps on reducing by some even number. It keeps on dividing basically or gets reduced by some even number. Here it was reduced by 4, here it was reduced by 2. Okay, so basically now here what I can say at the end what is remaining inside the array? Nothing is remaining, and now n has been reduced down to 0. Okay, so here basically what we are focusing on, this was an example in which the size of the array was even. Okay, the size of the array was even. Now let's take an example in which the size of the array is going to be odd, and in that case observe the output. Okay, so let's take n equals to 5. I'll take 1, 3, 3, and let's take 2, and let's take 4 over here. Okay, so 1 is occurring how many times? 1 is occurring once, 3 is occurring twice, 2 is occurring once, and 4 is occurring what? Once. So here you can observe the dominating element comes out to be 2, but it is not dominating. Dominating is what? N by 2, 2 by 2. Okay, so here this is a dominating element. Okay, so the example that we have taken, 5 by 2 is what? You will get 2. So this comes out to be dominating. So I'll change this to, let's take as 5. I'll change it to 5. Okay, so now here the see, I need to change because the example that we wrote down was of test case, was of type number 1. This is your type 1. So accidentally we took type 1 example, but we are focusing on solving type 2, right? So in type 2 there is no dominating. Dominating means element occurring less than n by 2 times. Okay, not dominating means. Okay, now 5 is occurring only once. So here you can observe all of them are having same frequency, or there is no dominating number. But then also I'll take maximum frequency. Maximum frequency of an element is what? 1. And I'll say, let's say I'll call it as 1. And the remaining element is what? N minus mx. That is here 5 elements are there. 5 minus 1, you will get 4. Okay, so here I have one element which I have taken as the highest frequency, and the other elements are what? 2, 3, 4 and 5. These are the remaining elements. What is the size? Size equals to 5. Now here size is odd. Okay, initially the size was odd, and when the size was even, you got the answer to be 0. Okay, fine. So now what I can do, how many elements will be removed? 2 into mx elements, that is 2 into 1, that is what? 2 elements will be removed. Yes, absolutely, 1 and 2. So now here observe, the size of the array will be reduced by even size always, because 2 into mx is even. So now 5 minus 2, what is the size? Size is equivalent to 3. Okay, fine. Now 3 elements are remaining inside the array, 3, 4 and 5. Now here 3 is occurring once, 4 is occurring once, and 5 is also occurring once. So I'll take maximum frequency as, let's say, 1, and I'll select the element as 3. The remaining element is what? N minus mx. N minus mx, n is what right now? It is 3. So that is 3 minus 1, I'll get 2. So here I'm talking about 3, and here I'm talking about 4 and 5. Okay, and what is the size? Size is equivalent to 3. Okay, so now 2 into mx elements will be removed. 2 into what? 1 equals to 2. Yes, 3, 4, they will be removed. Okay, so 3 minus 2 will be 1. Okay, here you can observe 1. Now the size is reduced by an even number, and the remaining array is what? Containing only one element, and that is 5. N equals to basically 1. So this is the output. Output says 1 because one element remains unpaired when there is no dominating number. So whenever, if you want to take one more example of odd size, and if you want to take one more example of even size, I can show you the example. When you don't have any dominating number, the output will always be either 0 or 1. Okay, that's for sure. Let's take one more example in which no dominating number, and I hope it's clear that dominating number has frequency greater than or equal to n by 2. No dominating number. Let's take even size array. Even size array. Let's take n equals to 4, and there will be no dominating number. Okay, so I'll take an example in which there is no dominating number whose frequency is greater than or equal to n by 2. I'll take 2, 3, 4 and 5. This is an example. Okay, fine. Now all of them are having one frequency, and here I can assure you that the output will be 0. Whenever you have even size array, the output will be 0 for no dominating numbers. Okay, so now let's take mx. All of them are having same frequency, so mx will be 1, maximum frequency. Let's take the element to be true, to be 2. N minus mx. What is n minus mx? 4 minus 2, 4 minus 1, that is 3 elements. So here I am talking about element 2, and here I am talking about element 3, 4 and 5, and the size of the array right now is equivalent to 4. Okay, so basically the size is equivalent to what? 4. Now, how many elements will be removed if I pair this 2 with one another element? So 2 into mx elements will be removed. 2 into 1 is what? 2 elements. Yes, absolutely. 1 and 2 elements will be removed. So now n is equal to 4. 4 minus 2 is equivalent to what? 2. Now size is what? 2. That means we have 4 and 5 elements are remaining. N equals to 2. Okay, fine. What is the maximum frequency? Maximum frequency is 1. Let's take the element to be 4. The remaining elements n minus mx equivalent to, that would be 2 minus 1, that is 1, and the element is 5. So how many elements? What is the size? Size equivalent to 2. How many elements will be removed in this time? I'll select one element from here and one element from here. 2 into mx elements will be removed. 2 into 1, that is 2. So now size will be 2 minus 2, that will be 0. So output says at the end here in even size the output will be 0 when you don't have any dominating number. One more example for odd size array. When the size of the array is odd and you don't have no dominating. Sorry for the bad handwriting, I can explain you, but I know you guys are here for the post contest analysis and I don't want to make this video much lengthy, right? So no dominating number over here. So no dominating number, size is odd. Let's take n equals to 7. Let's take a bigger example. So no dominating number means n by 2. That means 7 by 2 equivalent to 3. So there should not be any number whose frequency is 3 or greater than 3, because this is type 2 test cases. Okay. So I'll take 2, 3. Let's take 2, 3. I'll take now 4, 5 and 6. 3, 4, 5, 6 and 7. 7 elements. So now frequency of 2 is what? 2. Frequency of 3 is what? 2. Frequency of 4 is 1. 5 is also 1 and 6 is also 1. Maximum frequency over here. So there are two key points. I'll explain what are the two key points that you should keep in mind, okay, afterwards. So what is the maximum frequency is 2. So I'll take the element. Let's call the element to be 3. I'm selecting now the maximum element to be 3. Okay. What are the remaining elements? N minus mx. So that would be 7 minus 2. That is 5 elements are remaining. Now I will be having 3, 2, 2. Okay. And here it should be 3. Sorry. Here this should be 2 appearances of 3. Here should be 2, 2, 4, 5 and 6. These are the other elements. So I'll take one maximum frequency element, one non-maximum frequency element. Okay. So how many elements will be removed? 2 into mx, that is 2 into 2, that is 4 elements will be removed. Let's verify. 1, 2, 3 and I'll take 4. Okay, 4 elements are removed. Size was what? 7. Now 4 elements are removed. So size will be now what? 3. Okay. So now how many elements are remaining? 2, 5 and 6. Now size is what? 3. Now all of them are having same frequency. 5, 1 and 6 also 1. I'll take maximum frequency is equivalent to 1. And let's take the element to be what? 5 in this scenario. We'll write down over here. And the remaining elements n minus mx is equal to what? 3 minus 1, that is what? 2. Remaining elements are 2 and 6. So here I can take maximum frequency element and other non-maximum frequency element. So 2 into mx elements will be removed. Okay, every time I'm writing 2 into mx is that you guys can understand that every time the size will be reduced by some even number. Okay, it will be reduced by some even number. So 2 into mx is what? 1 into 2, that is what? 2. So now here you can observe two elements are removed, 5 and 2, that forms one single pair. So now n was what? N was equivalent to, earlier it was what? 3. Now it is 3 minus 2 is equivalent to 1. And here you can see one element will be unpaired and size of the array is 1. And in odd case you came to know that the output is 1. Now observe here. This was an odd case where there was no dominating number and output came out to be 1. Here this was odd case, odd size array, no dominating number and the output came out to be 1. And here this was even size array and there was no dominating number and the output came to be 0. Here there was no dominating number and even size array and the output came out to be 0. Okay, so now you can summarize this thing that for the type 2 test case in which there is no dominating number, the output depends upon the size of the array. And if n is even, then what will be the output? Output will be 0. If n equals to even, I'll write down n equals to even, then answer is always 0. And if n equals to odd, then answer is always equivalent to 1. So now in this scenario, can I write down the answer will be what? Answer will be n modulo 2. Is it valid? Do you think this is valid? Yes, absolutely. Modulo by 2 gives you answer 0 or 1 always. So this is the approach. I hope you got an idea. So basically you need to find out the maximum frequency element, and if it is dominating one, then output will be mx minus n minus mx. Okay, and what is this formula? I have already explained. You can go back and watch these things. What are these things? And if there is no dominating number, then output will be what? N modulo 2. That means for even size array, output is always 0, and for odd size array, output is always 1. So this example, this question basically needs you to observe like many test cases, and based on that only you will be able to find out the solution of it. Okay, so now let's see the implementation part. And one more thing guys, if you really are enjoying this editorial or this post contest analysis, then do hit the like button and do comment down your approach, like do comment down your approaches, and do comment down your views. How are you finding this approaches, and how are you finding this post contest analysis? That would be of great help, right? So let's see the implementation part of it. So here basically this is the approach of it, a very simple approach, and I am not writing down the code live because the video will be lengthier. The important part was that you guys can understand the approach very well with the dry run that I have shown you, and yeah, the solution is pretty understandable. So I'll explain each and every step. So here this is a approach in C++ language, and this is my vector over here, and this is the size of the array. Now what I have done, I have taken one variable mx, okay, that says the maximum frequency of any element, and I have taken a map to map the frequency. So what I have done, I have found the frequency of every element. Then what I did, I iterated over the map and I iterated over the frequency of the elements to find out what is the maximum frequency. Okay. Now if I get the maximum frequency, that is what? The remaining elements, see this is the case for dominating number. If n minus mx is less than or equal to mx, then output will be what? 2 into mx minus n. This is similar to what we have seen right earlier, mx minus n minus mx. This is same, or you can write down as 2 into mx minus 1. Both means the same. Mx minus n, right? Both means the same only, right? If you remove the brackets. And other one is for non-dominating number. At that time, you know, when n is even, the output will be 0. So n modulo 2. Let's try to compile and let's try to see the submission. Working perfectly fine, and let's try to submit it. And we can see that this problem has been successfully submitted. Okay, so this was the minimum size of the array. And if you are really enjoying these solutions, then do hit the like button. Let's keep a target of 30 to 35 likes in this video, and do comment down how are you finding the approaches in this contest. This was a quite interesting problem.